digits. Okay, digits in the sense when we are doing any operation, addition operation or multiplication operation, we need to know the last digit which is going to arrive. So there are a lot of problems in IOQM number theory which they are asking for the last digit of a particular operation. Not only the last digit, they also want us to predict the last two digits. So we have to understand some of the basics before we go to this topic. So in your lower classes, you have made multiplications in tables. You know the tables, right? But now you have to understand how the tables are having some pattern. Okay. For example, if I say 0 is there, if I make a square, a3 or a4, 4, so what will be the last digit that we will just look at. So if I make a square of some number which is ending in 0, it will be 0. Again a cube 0, all the time the 0 will be there. So imagine there is a number like 10. If I square, again multiply, the last digit will always be 0. Similarly, for 1, the last digit will also be 1. For example, there is a number 21. Okay, if I multiply 21 by 21, we will get 1 on the last digit. So last digit will all be 1. So there is no cyclicity here. Okay. Similarly, if I square this number, okay, if I square this number 2, so I get 4 followed by 8 followed by 16. The last one is 6. Then followed by 2, again 4, again 4, sorry. So I get 4, 8 and 6. So it keeps on going like this, right? So there is some pattern. Yes, there is some pattern, but it is not like 1 or something else, right? So it is having some cyclicity. We can say there is a cyclicity. Cyclicity means after few terms, the terms are repeating. See, it starts with 4, 8, 6. Then again it goes to 2, 4, 8, 6. So similarly, if I go to number 3, okay. So if I go to number 3, I think it's slightly low. So if I go to number 3, what happens here is is 3 square is 9, then into 7, 3 into 7 is 7, again 3 into 7 is 21, 1. The last digit will be 3 into 21 into 3 is again it is 63. Okay. So after 3 digits, so after 3 multiplications, this has become 3 again. So again this 3 will become 9, 7 and 1. So if I say 4, 4 into 4 is let us 6, again 4. Again 4 to 4, 6. So 4, 6, 4, 6, 4, 6 will be there. So there is a cyclicity of 2 here. Alright. Okay. Here if I see 5. So 5 square is 5. So all the 5 terms will all be 5. There is no change. The last digit will always be 5. Hope you all understood this concept, right? So here you see what we have done is we are finding out the last digit of any multiple of a particular number. So especially 2 square, 2 cube, 2 power 4, 2 power 5, all these things are having, there is a pattern here. So you have to understand there is a pattern, and if you know that pattern, you will be able to easily solve any problem given finding out the last digit in the last one digit. So here again I come to 6. 6 if I multiply to 6, again 36. 6 into 6, 6. So 6, there is no change. It is all same. It is like 0 and 2. So 0 and 1. Any number 0, 1, 5, 6 and all have one cyclicity of only 1. So similarly for 7, if I say it will become 9, become 3, 1, again 7. 7, 9, 3, 1. So this is how it happens. And again 8, if I say 8, 8 into 8 is 64, 4 into 8 32, again 8 into 6 is 2 into 6 is 2 into 8 is 6, 6 into 8 is 48. So again after 4 numbers 8 has come. Again if I multiply it by 8 become 4, 2, 6. So again cyclicity is 4. So for the number 9 it is 81. Again 9, 1, 9, 1, 9, 1. So for 0 it is always 10 is always 0, right? 0, 0, 0, 0, 0, 0 and 0. So you have understood that there is a cyclicity for, what is the cyclicity for? 6, 7, 8, 9, 10 as well. So let us go to the other, let us go to the next also. So to summarize, okay, the cyclicity of 0, 1, 5, 6 is same. You multiply any number of the same number, you will get same. Not only for this 5, any number multiply completing with 5. Okay, 15 also, if you multiply again and again, you will get the last number as 5. And 6 also, like for example, there is number called 26. If you multiply 6, 26, 26 again and again and again, even for any number of times, it will be the same. For 4 and 9, the cyclicity is 2. Because the first number 4 is 4 into 4 is 16, then again 4. So 2 number cyclicity is 2. So for 3, 7, 8 it is 4. Because for example, if I say take 2, no, first there is 2, then followed by 4, then followed by 8, then followed by 6, and again then 2 will come. So 4 is the cyclicity of 2, 3, 7, 9. So any number of digits that are divisible by 4, you will get the same last number. We will see some problems in this. So find the unit digits of 173 power 37. So here we have to note down that they have given 37 times. Like here we saw about 8, a power 8. No, now they are asking. Here we are saying till a power 8. Okay, so it is clear. This is till a power 8. Now they are asking some number a power 37. So what do we do? So 37 has to be taken into like multiples. 37 can be written as what? 37 can be written as 37 can be written as 7 into 5 plus 2. Okay. So what is the cyclicity of 3? You know that 3 has the cyclicity of 4 numbers. 3, 9, 7, 1, and then again 3 will come. So 4 is there. So let me write 35 like this also. You can write 35 like this also now. So 37 can be written as 9. 37 can be written 9 into 4 plus 1. So 9 into 4 is 36. 173 power 36 will end in number 1. But there is one more quotient is there. So 173 power 37 will end in number 3. 3 is the answer. So the last digit of is 3. Had it been 36, okay, 173 power 36, the number will be 1. The last one, had it been 35, it would be 7. So it goes. So this quotient is important. Now what is the remainder? Based on the cyclicity, you have to find out. The cyclicity is 4. So what is the remainder? Then the cyclicity, according to that, the last digit will occur. So find the unit. Just a minute. Find the last digit of the number 1989 to the power 1989. So here the last digit is 9 and 1989 is given. Okay. So what is the cyclicity of 9? Cyclicity of 9 is 2. A power 1 is 9. A square is 1. Then finally it becomes 9191. So you have to divide this by 2. Okay. If I divide this by 2, what will happen? Divide this by 2, what will happen? 4. Okay, 994 into 2 plus 1. 2 is the cyclicity. So it would have been 994. Had it been 9988. Okay, 9988 means the last digit would have been 1. But now they are plus 1. So last digit of this is number 9. So that is the answer. So the last digit of this number is 9. Had it been 9, had this been 9998, no. So what happened? There is no remainder. There is no remainder. So cyclicity is 2. The number will end in 1. So number will end in 1. Okay. So find the last digit of this particular whole equation. So now we are getting complicated. Okay. Now we have to find out the last digit of this term, this term, this term, and then multiply these three. You will get the final answer. So now 3 has cyclicity of 4. You all know that. So 3 has a cyclicity of 4. So like 3, 9, 7, 1 again 3. So if I divide by 4, what will be the remainder? So 1999 divided by 4. What will happen? 4 4s are 16, 3 9s are 4 9s are 36, again 3 4 9s are 36, 4 9s are 36. So 199 can be written as 499 into 4. So what will be the answer? Plus 3. Okay. Plus 3 will be the final remainder. So here the cyclicity is 4. So 499 into 4 is over. So 3 numbers. So 1, 2, 3. The last digit of this will be 7. Understood? Because if you see the cyclicity, it is 4. So if I divide this number by 4, I am getting 3 as remainder. So if I get 3, I get 1, 2, 3. I will count. The last digit is 7. Similarly, 7000. What is the cyclicity of 7? 7 will be 7 into 7 is 79. First one is 7, followed by 9, then followed by 3, then 1, and then again 7. Okay. So here also cyclicity is 7. So 2000 how can be written? Cyclicity 4 can be written as 500 into 4. Okay. So 500 into 4, last digit will be 1. Then 17. So we don't bother about the previous terms and all. So we have to bother about the 7. So again the 7 is there. Cyclicity is 4. So 2001, how can it be written? 500 into 4, sorry, into 4 plus 1. So all the cyclicity 1 will be completed. Then the remainder 1 you have to take 7. So this is 7, which gives you 7 into 1 into 7 is 49. So last digit of this 49 will be 49, but final digit will be 9. So that is the answer. So now that we have known a lot of things about 7, the last digit. So now we are going to last 2 digits, which is quite interesting. Okay. So last 2 digits, okay, of 5 power n will always be 25. That is what the logic says, and you multiply. You see the numbers 125, 625, 1025. Everything is having a final remainder as 25 only. So 6 power n. So there is a cyclicity for 6 power n. 6 power n, what is the cyclicity? 36, 16, or 96, 76, 56. So it has cyclicity of 6. It has cyclicity of 6 power 6 squares 36. So 6 power 1 is, so what? How you want to understand this is, if you have 6 power 0, okay, what is the last 2 digit? 6 power 1 is 06. You start from 06. That is the right way to understand it. 06, 36. So 1, 2, 3, 4, 5, 6 is the cyclicity of 6 power n. Similarly, 7 power n, we can say that 07, 09, 03, 01. So it does again it will become 07. So 7 power n has a cyclicity of 4. And then 76 power n, that's a special case. If any number is final number is 76. So the final number, last 2 digit of all the numbers of 76 will be, all the powers of 76 will be 76 only. So let's go to some problems. Find the last 2 digits of 6, 1, 1, 2. So what is the cyclicity of 6? 6 power 1, last 2 digits cyclicity 6 we are saying. So how can I write 112, 112? I divide by 6, what I get? 1 times, 5 times, 8, 4. Okay. 18 into 6 plus 4. So as we seen already, the number starts with 06, then 36, then 16, 96, 76. 16, 76, and 96. So there are 4 cyclicities remaining. So 1, 2, 3, 4. So I take this 76 as a last number. So answer is 76. Okay, the last 2 digits of 6 power 112 is 76. So there is a generality there given. So if there is a big number A18, so for example there is a big number and then there is a big number, okay, there is a big number. So final is A minus 1 is AM, A minus 1 and AM. So whatever the last big number is there, the last two digits have to be taken and the power of that two digits will be the last two digits that they are saying. For example, the last two digits is completing in 76. Some big number is there, 1, 2, 3, 4, 5, 76. So what will be the last two digits? It will be the power n is there, okay. So last two digits will be the 76 power n. So as we seen in previous single digit also. So we want to find out the last digit of this, I will go to take 6 power n into consideration. Rest of the thing doesn't matter to us. Similarly here, you have to find out the last two digits, so it will be the last two digits of this big number. You do not multiply this big number n number of times and find out. So there is a shortcut to find out this answer. So the last two digits of 2 power 110, what is it? So here the cyclicity of 2, we can say 02, 04, 08, 16, okay. 16, so on and off it goes, okay. So last two digits of 16, 64, 128, this is 1, 2, 3, 4, 5, 6, okay. So 6 again, if it goes dot dot dot, 2 power 10 will be 1024, okay. So last two digits of 2 power n is 24. So now there is a big number, so there is no generalization here. So what you have to do, you have to divide it into 10 or 20 or 30 to find out. Okay, 2 power 10 or n has to be found out like in these terms and you have to find out. So in order to find out the answer, it will be, so we have to take this number 1120. If I convert into factors, it will be 20 into 56. So 20 I can find out because I know 2 power 10 is 1024. So 1024 into 1024, I will get the last two digits as 76. Okay. So this 2 power 20 into 56, right? So 2 power 20 is 76. 76 power 56 will always be what? 76. So the answer for this number is 76. So you have to find out this 2 power thing and then you can convert it into the rest of the digits. Find the last two digits of 6 power 100 and 7 power 81. Okay. So here the cyclicity of 7, let us see. 07, 49, then followed by 43, then 01 and again 07. Okay. So cyclicity of last 4 digits is 0. Similarly, we know about 6, right? Always the last two digits will be 06, 36, 16, 96, 76, etc. etc. So here, if I divide this by 5, okay. So this is 6 can be written as 6 power 5m plus 7 can be written as 4n plus 1. Okay. So 4n plus 1. So 1 is remaining. So here the cyclicity of 7 is 4. So since there is 1 remainder, I will take the last number as 07 plus here 5m. The 5th digit will be 76. So 76 plus 07 is equal to 83. This is the last digit of 6 power 100 and 7 power 81. So whatever the number you know, you can arrive at the answer for this. Okay. So for 2 it is very specific case because the last number ends with 2 power 10 ends with 24. 24 and 24 is 76. 76 once it arrives, all the numbers of 76 will become it will be the same number. So if you are getting somewhere at 76, it will be easy for finding out the last two digits. And last two digits also you can do all the operations. For last 2 digit or last 1 digit, you can do multiplication operation, addition operation of the last 2 digits of the separate terms. So you cannot combine directly, but you can just do an operation with this and find out the final answer. So this is an introduction, and you can do a lot of these problems when it comes to the question paper, or we will give you one worksheet for working on this last digits and last 2 digits. So today's topic is this. So prepare with this, and again more knowledge about the numbers, the first four, and also combinatorics will be taught in the coming classes. So these two are very important. The first four. Once you understand this algebra and this geometry will become more easier for you.